Let's see the schedule-based protocols. The schedule-based MAC protocol is a communication protocol. It is used for access nodes in the shared medium. It's divided with respect to time and pseudocodes. It allows the different time, frequency, and pseudocodes. It allows the different nodes to access the shared channel without collision. It is energy efficient protocol and hence they do not waste energy in collision and ideal listening. Examples of schedule-based MAC protocols are low energy adaptive clustering hierarchy, power efficient and delay aware medium access protocol. Schedule basis protocol is based on strict time synchronization requirement. Low energy adaptive clustering hierarchy, LEACH. Low energy adaptive clustering hierarchy or LEACH is a time division multiple access MAC protocol with clustering features. A network is formed as a star topology in two hierarchical levels as shown in figure. A cluster consists of one cluster head and number of ordinary nodes. All the ordinary nodes communicate with the cluster head directly. On the other hand, there is a single base station which communicates with all the cluster heads. Direct communication with high transmission power is used in order to ensure the cluster heads can reach the base station. The cluster head aggregates the data of its members and transmits it to the sink node or the other nodes for further relaying. For a member, it is typically much cheaper to reach the cluster head than to transmit directly to the sink. The cluster head's role is energy consuming since it is always switched on and is responsible for the long range transmission. If a fixed node has this role, it would burn its energy quickly, and after it died, all its members would be headless and therefore useless. Therefore, this burden is rotated among the nodes. Specifically, each node decides, independent of other nodes, whether it becomes a cluster head, and therefore there is no signaling traffic related to cluster head election. This decision takes into account when a node served as cluster head the last step, such that a node that has not been a cluster head for a long time is more likely to elect itself than a node serving just recently. The protocol is round based, that is, all nodes make their decisions whether to become a cluster head at the same time. The non-cluster head nodes have to associate to a cluster head subsequently. The cluster heads choose their cluster head based on received signal strengths. The network partitioning into clusters is time variable and the protocol assumes global time synchronization. After the clusters have been formed, each cluster head picks a random CDMA code for its cluster, which it broadcasts and which its member nodes have to use subsequently. This avoids a situation where a border node belonging to cluster head A distorts transmission directly to cluster head B, shown in figure. Figure shows the intercluster interference. A critical network parameter is the percentage of the nodes that are cluster heads. There are only a few cluster heads. The expected distance between a member node and its cluster head becomes longer, and therefore the member has to spend more energy to reach its cluster head while maintaining a given bit error rate target. On the other hand, if there are many cluster heads, there will be more energy expensive transmissions from cluster heads to the sink and less aggregation. Therefore, there exists an optimum percentage of cluster heads. Each can achieve a 7 to 8 times lower overall energy dissipation compared to the case where each node transmits its data directly to the sink, between 4 and 8 times lower energy than in the scenario where packets are relayed in a multi-hop fashion. The protocol is organized in rounds and each round is subdivided into a setup phase and steady state phase. Figure shows the organization of the leech rounds. The setup phase starts with the self-election of nodes to cluster heads. In the following advertisement phase, the cluster heads inform their neighborhood with the advertisement packet. the cluster head content for the medium using the CSMA protocol with no further provision against the hidden terminal problem. The non-cluster head nodes pick up advertisement packet with the strongest received signal strength. The following cluster setup phase, the members inform their cluster head, again using a CSMA protocol. After the cluster setup phase, the cluster head knows the number of members and their identifiers. It constructs a TDMA schedule, picks a CDMA code randomly, and broadcasts this information in the broadcast schedule subphase. After this, the TDMA steady-state phase begins. Because of collisions of advertisement of join packets, the protocol cannot guarantee that each non-cluster head node belongs to a cluster. However, it can guarantee the nodes belonging to at most one cluster. The cluster head is switched on during whole round and the member nodes have to be switched on during the setup phase, occasionally in the steady-state phase, according to their position in the cluster's TDMA schedule. Limitation of leash. Leash would not be able to cover large geographical areas of some square miles or more because cluster head 2 miles away from the sink likely does not have enough energy to reach the sink at all, not to mention achieving a low bit error rate. If it can be arranged that a cluster head can use other cluster heads for forwarding, this limitation can be mitigated.